Hello and welcome back to API Can Codes Unit 1, Data in Learners' Lives. Today we're going to be talking about Lesson 5, where students learn to evaluate datasets using the 5Vs model. This is a model for evaluating data sources based on a number of metrics. They're going to practice using this model on a Starbucks dataset, modeling growth through the years, and then apply the 5Vs to their own project ideas. Our warm-up today has students guesstimate some numbers, some statistics for different features of Starbucks. It's best if students don't Google on this slide, and it's best if they do write their answers down. We do have these questions on the worksheet, so they can just do that there. But then they can actually refer back to these later when we give them some numbers. The recap of lesson 1.4 will probably cover primary and secondary sources of data. You might talk about the Selfie City project that students looked at last lesson and any of the other project pieces that they did. Our data set today is about Starbucks. We found it most productive to frame this as sort of the teacher's own question. Has coffee consumption increased over the last 2 decades? And then you can sort of model it as if you were looking into that question. Important to emphasize to students that this is a secondary source. It has been aggregated from a variety of primary sources, but in aggregate, it is a secondary source. And this is a bunch of Starbucks yearly data from 2009 to 2022. Just a note from me that most of this data is as real as possible, which is to say I took the publicly available data that Starbucks publishes and provides. I did have to sort of guesstimate at some in-between years because the data wasn't there for all years for every item. So a few things, especially menu items, are a little bit hand-wavy, but they're as close as I could get them. So these are the 5Vs that we'll be talking about today: volume, velocity, variety, veracity, and value. Our suggested approach is to discuss each V in theory, and then discuss whether the Starbucks dataset appears to meet the demands of that V. Students will then do a similar activity with their own project afterwards. So again, there's a couple ways you could do this, but we recommend sort of framing this as a large-scale class discussion where you sort of just go through each of the Vs together with students and see if it meets the demands of that V. The first is volume. What we're really focused on here is the amount of data being collected or analyzed, and is there enough to answer the question posed. For each of these Vs, we will have a prompt for students to respond to this on the worksheet in addition to the class discussion. Sort of once you've talked about it, maybe they write down an answer. Our next up is velocity. This has to do with when the data was curated, whether it includes real-time data, and how long it took to process and analyze the data. Since our Starbucks dataset is a couple years outdated, that might be an interesting thing to talk about with students. For variety, we want to think about what data types it includes and how the data is structured. Students will probably recognize that this Starbucks dataset is in tabular structure, meaning sort of those rows and columns. Our veracity V has 4 sort of subtopics: accuracy, reliability, completeness, and data biases. We'll talk about each of these on its own slide. For accuracy, does the data source provide metrics that line up with known metrics? So if students know or have a sense for what the real world numbers are, they might use those to sort of verify the data in the data set. And of course, data should be close to those known numbers or match them exactly. For reliability, we know that some measuring instruments and designs may reliably measure data and others may not. So a malfunctioning thermometer, for example, would be like obviously bad reliability. And I don't think that's as apparent in the Starbucks dataset, but students might see this more in their own datasets. As far as completeness, we want to see if there's any missing data. So we want to check to see if the dataset has a lot of missing data points or if it all seems to be there. The last topic within veracity is the data potentially biased? Students have talked about representation before, so you might ask them the question, are there any populations here that are over or underrepresented? Are there any cases of reporting bias where subjects might be sort of incentivized not to answer a question truthfully? Or is there, again, measurement bias, where a measuring tool might be systematically measuring something inaccurately? Our last V is value. And here we're going to look at the relevance of the data to the question being asked. So as far as the coffee consumption topic goes, if I want to look at coffee consumption and I'm only looking at Starbucks, that's not necessarily terrible because Starbucks is a pretty big coffee company, but you might be missing a piece of the picture. And students might point that out and say there are other companies that sell coffee. There's other metrics that might be better for looking at this. So at this point, the class has gone through the coffee data set and evaluated that according to the 5 Vs. We recommend at this point that we split into small groups and that each student sort of goes into one of those sources that they identified in the previous lesson for their local area project and look on the internet for a data set for this source. Kaggle, OpenDataDC, and Rapid API are all decent databases that students might use to find a data set in one of these topics. Some students will just go ahead and Google it and see what comes up. That's generally okay too, but you may want to sort of vet some of their sources as you go around. They will have opportunities to sort of find a better one as we go through this unit. So what we want students to do is evaluate their data set using the 5 Vs. They should talk about each category with their small group to get some sort of peer feedback there, make sure they're thinking about that the right way. Our exit ticket today is matching each of these scenarios to the V from the 5 Vs that they do the best job of representing. So we have a researcher collects 10,000 responses to a survey on favorite color. That is hopefully obviously volume. A student uses an API to collect live updated data. This is a velocity one. We're talking about real-time data. A professor using a verified government database that speaks to veracity. A company using not only survey data, but also interviews and field testing data is speaking to variety of data types. And the San Francisco Zoo deciding to use a new research paper specifically about gorillas instead of one written about chimps is speaking to that last V, value, because they're looking for a data set that's relevant to the question they want to answer. As always, thank you for tuning into this video and thank you for using this curriculum.